We're just winding down now in the course, so what I want to do is, at this point, we've kind of reached the capacity of the things we can cover in this course. What you're looking at here is something that's just a bridge too far for the amount of time we have left. But you could actually do this. This isn't a hard thing to do. I'm going to show you how to incorporate motion into our programs. But you have to make it someplace else. That's the problem. You can't. I can't show you how to construct the horse and put texture on it and all that stuff. That's done in a separate program. But in order to do it, you have to get that program. And Blender is the one I suggest, because Blender, which is, I believe, written by someone in Germany, they've kept it up for years and they've kept it right up to date. It's a very formidable graphics program. It's one of the best ones, and it's free, which is kind of cool. What it does is, the way Blender works is, you get a screen that gives you the ability to construct things, and they got all kinds of doodads that you can do, create this and that. And when you finally construct your thing, the thing you want, you can also animate it. You can make it go through different animations, whatever you want them to be. And then what you can do is you can save that as a JavaScript file. And that's where we pick it up. In other words, once they save that as a JavaScript file, it gives you options on how to save stuff. You save it as a JavaScript file, and then I'm going to show you the code we use to get it into how we incorporate it into our programs. When the horse first comes, let's start off with the flamingo here. Well, let's see what it is. Maybe the horse is better. Let's see what it is. Yeah, there's the horse. When you first get the horse in Blender, this is all it will do. It'll just simply run. It won't do anything else. It won't move. So what happens is, if you want that horse to move around, you have to actually treat it like an object. You have to say, move the object. Okay? It's internal motions, all its running and galloping and all that, are all set for it already. All we have to do is get it to act in the world that we've created, so it moves around and whatever. In Blender, you can actually create an animal that has 5 or 6 or 7 or 8 different moves, all different kinds of moves. And you can say, do this now, then do this later, do that. No, it's stand here, sit down, turn. You can make it. You can actually build those things in Blender, and then you can have that character do each one of those steps, or you can link them all together. We can do it different ways. But for our purposes here, what I'm interested mostly in is getting the character into our program and just getting it to do something for us that we want it to do. So the first step of the thing is you have to get the character into the program, and that's what this program here does. It just brings the character in. I've added a few other little things just for fun, shadowing and shading and so forth. But the basic thing is to get the character into your program. So that's step number one. Let me show you the code that does that. I think I'll go here. View page source right here. To begin with, assume that you have your room set up and your walls and your floor and everything's all set up. And then you want to bring your character in. Well, if you look down at the bottom here, can you read that line at the bottom? Or is that too small?
That's good.
You can see it okay?
Yeah.
Okay, you're the furthest guy back, so I guess you're okay. Unless anybody else needs a white cane. Okay, so if you look at this thing, it's a script. And this is just like you bring any character, anything, a sphere, whatever you're creating. In this case, what you have to do is, you have to look at the name of the file that Blender created. You give it a name, whatever it is. Well, what I did is I said, I want this thing to be named horse. And then it added a JS to the end of it, which made it a JavaScript. So now I have a file, and it's called horse.js. That has to be just like a picture or anything else. It has to be in your folder with your program. And then all you simply have to do in our program is simply say animation. That's the only thing you have to say. Open parentheses, and in quotes, put down the name of your file, the JavaScript file, whatever it is, and then semicolon, and slash script, and that's it. Now you have the character in. All of the characters that you bring in, you only bring in one character, by the way, in this program. It's only set up for one character. The character you bring in, it always is called mesh up in the up in where it's rendered. So up in here someplace, I should find, there it is right there. You see that section right there? That's the mesh. That's no. Once you say I want this character, you say animation. That character comes in, and it's given the name mesh right away. And notice that it doesn't have any kind of. It isn't called a plane or a sphere or anything. It's just mesh. Then you say dot scale dot x. What I did is, when they make the character, it's in a world. It's in the Blender world. And you make it wherever you want it. And that's like I've always said about this program. It's the size is whatever you want to make it, because these numbers don't mean anything really. They're only proportional. So in other words, if you go 5 up or 5 to the right, that's the same length. And that's all it does, is it makes the x, y, z on the same coordinate system, same length of coordinates. So in this case right here, the horse was too big. It actually filled my screen too much. So I cut the horse in half. And I did that simply by scaling the x, y, z to 0.5. What that did is shrunk the horse down. So I brought it in and I shrunk it. And then I positioned it at 0, minus 100. The reason why it's at minus 100, when I brought the horse in, it was in the wrong position. It was too high. So I brought it down, okay? In other words, when they build a structure in Blender, they put the 0 position someplace. And it may not agree with, you may want the 0 position up in the middle of the horse, but it's down at the bottom. So basically, when they give it to you, you look at it in the screen, you say, oh, that's in the wrong place. So you have to move it into a proper position. So what I did was, I moved it minus 100 and moved the horse right onto the stage, which is where it should have been. Then finally, the only other thing I did, notice I have positions and rotations. The only other thing I did is I turned the horse 90 degrees because it was running towards me. And I wanted to see a broadside view of it. So I simply gave it a 90-degree turn with this instruction right here. I could have given it a plus math dot pi over 2, but I gave it a minus math dot pi over 2, okay, to get it to turn that way. Okay, that's the negative direction for the rotation over y. So then when I get it in, now what you have to do is one more thing. To get the horse to actually do its bit, you have to say animate. There it is right there. It's just animate, open, shut, and nothing else to do. And the reason why you have to put anything in there is because you can only have one mesh in this program. And when you say animate, it knows it's just that mesh. That's all you have. So there's 2 words that you have to learn. That's really quite simple. Animation is how you get it in, and animate is how you make it move. And then what you do is, in this case right here, in this program right here, which I should look at again, right here, the horse is just set in position. I basically, it was sort of galloping towards me. I just turned it 90 degrees and it's galloping to the left now. And this also has lights, but that's just because I just took a program I already had with lighting in it and just threw it in there. So that's how you get the character. And now if you want the character to move, you have a different situation. Because now what you have to do is, going back to the program, you have position X, Y, and Z and rotation X, Y, and Z. Those are the way you control any object on the screen, no matter what it is. And in this case, what you're controlling is not only the object, the galloping is part of the object. So in other words, if it gallops and you turn it this way, it'll still be galloping. It just does what it does. So no matter which way you turn it or bring it up or down or whatever, it's going to continue to do whatever motion that the thing was built in Blender to do. So now you get this character. So supposing, which I did in the initial opening, supposing I wanted to make that gallop, I wanted to make it go around in a circle, okay? So let me go back to the previous program here. I'll get rid of that. Back to here. Now I'm going to take this horse and I'm going to move it around in a circle. This is the circle program right here. And the reason why it looks like it's slipping here, it actually runs very well if you don't have this frame. The frame thing slows everything down, so some of the things you see are not as they're not as bad as they look on the screen. I just turned off the ambient and put on the left and right lights. And that's what you get. You should get a couple of shadows. And by the way, while we're talking about this, let me talk about shadows just because I happen to be talking about it. When I set up the shadows, what I've done is I've set them at 500, all of them at Y500. And the reason why, when you think about it, you have an object. In order for it to have a shadow on the floor, the light has to be above it. There's no other way. And these objects are at 0. And everything's at 0 to start with. And usually you're moving them left and right and so forth, but not very high or very low. 500 is above the roof. The roof is 100 high. So 500 is way the heck up there, which is good because we want it outside. The ceiling won't affect it because you haven't told it to make a shadow or anything. Don't tell the ceiling to make a shadow, because if you do, if you make the roof make a shadow, it'll block the light. You won't have any light. So in other words, the ceiling should have no shadows on it. So what happens is you tell the objects in your world to cast a shadow, and you tell the floor to receive a shadow. That's what you got to do, because if you don't have both of those, it won't work. One casts and the other receives. Now you may wonder why they do that. Why don't they just say make a shadow? The reason why is because every calculation for shadows is very expensive computer-wise. It slows things down quite a bit. You don't notice in our programs because we only have one object, it doesn't do very much to it. But if you had 100 objects and they were floating around all over the place and they were casting shadows, your machine would slow down a lot if it made shadows. If you turn the shadows off, you'd see it move much faster. Because what it has to do is, it's a very complicated process. It takes the shadow and makes this like light cone. It's a calculation. And then when it sees an object inside of that cone, it has to calculate which way those vectors are going from the light to the floor, and it has to do a calculation. So every calculation it has to do for every shadow is very expensive. If you had 10 shadows and 10 objects in there, and you only shadow one of them, you'll see the thing move at a certain speed. If you turn the shadows on all 10 of them, you'll see it move a lot slower. Okay, yeah.
One thing I was curious about is, I know you mentioned that, like, the shadowing is a lot of work, but still it slows down the machine. Is it just because there's no shadows that something like the sprites is possible to run without bogging down the machine to the point of not?
Wait a minute. You're saying you turn the shadows off?
No, but I'm curious. Like, I get that the shadows add a lot more
Calculation.
Yeah, but if it's that much more, then how is it possible to have like hundreds of objects with a sprite effect and that doesn't bog down the machine to the point of?
Oh, you mean like when our multiple
like when we have
sprites? The sprites, yes.
Yeah.
Because sprites are just flat little images. They look round, but they're not. The thing with sprites are, which I don't know if you've noticed it yet or not, but if you got a bunch of sprites around you and you move through them, they always look at you. They never look in any direction other than at you. That's how they're made. So there's little flat things. There's nothing to them. They're like maybe a couple of points, nothing there.
Right.
And what happens is to move those around, nothing to it. Easy calculation, no matter how many there are. In fact, I put 100,000 on one of them and it worked. It's 100,000 points. But a calculation like this could be easily start consuming 100,000 because it has to look at every pixel. It has to know if that pixel is black or white underneath it, black or not. So it has to calculate every pixel that's in the shadow. In the umbra they call it. Yeah, so like in this case right here, this thing's got two shadows showing now. It's doing that calculation completely twice, once from the point of one light and the other from the point of this light. So it has to calculate every point on the horse and every point on the floor to make sure that it gets the entire shadow. It's all you have to do is experiment. You just add shadows, take away from things. You'll soon see what happens. But with modern computers, it isn't. You might not even notice it. It might be almost invisible to you.
Non-existent or not noticeable.
Yeah, it's hard to know, and it might depend on whether you have a quad or what kind of machine you have. It would probably make a big difference. I suspect that the new Macs run really fast with this stuff. I think they do. But
even my whole machine is older that I've done some of the work on. It's a Mac. But
well, the interesting thing about a Mac is it's hard to write the stuff, but it's easy to run it. Things usually run on a Mac really well.
I've had good work once I already have my program online, editing it in Alta Vista from a Mac, but not initially writing it.
Well, let me tell you what the problem with the Mac is that I see. This is my vision of it, and I worked with Macs. I built the first Mac lab at the school. I was with Macs for a long time, and they're very, very good. They're the best machines there are. But the problem is this, that the Mac's philosophy is to keep people away from programming. It helps you with everything. It does everything for you, okay? And the trouble is, when you're a programmer, you want to break through that stuff. You got to get in there. And the trouble is, they put obstacles there, not intentionally, but what they did is set it up so you don't trip into it accidentally. It is not something you'll have, and in order to make it work, you have to do some stuff to get in there. That's where the problem comes in, and that gives you that's the resistance they give us. And the thing is that every single thing on the web is run with HTML. And you can't write HTML easily on this machine, on their machines.
Because I've tried in Safari, and I've just been curious. It's hard to go view like the page source inspector of the coding.
I wouldn't use a Mac for this course. I just basically have decided that I've gone through too many renditions of it. I mean, first of all, there's different Macs. That's the first problem.
Oh man.
And the operating systems don't quite work the same way, and that's a real big problem.
They're mutually incompatible with each other.
Anyway, I just want to tell you that the Mac is fine at running stuff, though. It runs it perfectly well. Okay, so let's get back to this. So what we have here is I've taken a horse, which we only did one thing to. We just simply twisted it around 90 degrees, and we shrunk it so it would fit. I scaled it down, and that's all we did in the first program. And this one here, I have the horse running around. Now, before I even talk about how it's done, there's some things you should notice here. First of all, he's running around some point in the middle here, which is the midpoint of the whole floor. I imagine it's the origin. And he's simply running in a circle around the origin. And another thing he's doing is he's leaning over to the inside of the circle. All of those things are done by some calculations. You have to make a calculation someplace to tell it what to do. Let me tell you what the problem is. Let me bring up a paint program here for a second. This one right here. Okay, now here's the horse. I'll call the horse as like a stick right here. Normally, when we first ran him, he was just like this. He was just sideways to us, and we're over here looking at a horse just like that. But now what I want to do is something different. Z. There. Now what I want to do is different. Now what I want to do is I want to have the horse run around this circle right here, like so. Like he's running around. And this is the radius of that circle, okay? And what I'm saying to the horse is, run around this circle right here. Well, we have a function you can call. Actually, there's two of them. One's called gox and the other one's called goy, which we've used in other things before, but I'll show it to you in a second here. But basically what gox and goy does, which is kind of cool, you simply give it the radius of a circle, and you give it the angle that the circle is, the angle of the thing you want it to be at. In other words, the horse is here, then the horse is here, then the horse is here, which is a different angle. It's always a different angle. So once you give it those two numbers, the radius and the angle, it will put the object in that position on the screen. In other words, once you know the radius is assumed to be 0, once you know what the radius is, and you know the angle that the radius turned at, it'll be able to calculate where the horse is now, or where anything is that you go around. It'll calculate where it is. So that's the first thing. So what we want to do is, step number 1, is we want the horse to be constantly located every frame. As the frame comes up, we want to say, where are you now? So to make that happen, what we do is we have the angle turn a little bit, draw the horse, draw a little bit, draw the horse. So what we're doing is we're saying, you got the same radius, and go X, go Y, say the horse is here. And then add a little bit to the angle, then go to go X, go Y, and it calculates a new location. So it just keeps doing it for you, and you keep showing the horse in those locations. That's the first step of the thing, and that's the straightforward one. A different situation is this. The horse is over here. Look, he's facing in that direction. But if the horse was over here, now he's faced in that direction. He's facing a different direction. So not only is the horse moving from different positions, he's also turning every time he moves. He turns, okay? But that's easy. That's easy to figure out, because the thing is, whatever angle this is at right here, the horse is perpendicular to it. It's always perpendicular to that angle. So if you know the angle that the radius is at, you can simply say, put the horse perpendicular to it, and he'll be in the right direction, because he's always perpendicular to that, whatever that angle is. So you keep adding to the angle as he goes around, which calculates where he is, and then you look at the angle and you say, make the horse perpendicular to that angle, and it turns it from here over to here, and now he's in the right position. So the thing is, it takes a few calculations. One calculation tells you where the horse is located, okay? The second calculation tells you that the horse is pointed this way, or this way, or this way, or this way. That's the second one. And the final calculation, which is actually a pretty easy one, is if you want the horse to lean into the circle, don't forget, the horse's X, Y, Z is always the same. No matter what position he's in, his X, Y, and Z are always the same. So his Z goes out the front of him in a plus direction, and it goes out the back of him. So what happens is, if you want the horse to tilt over, you rotate him on the Z axis. And you always rotate him the same angle on that Z axis, because no matter where he is, you want him on that angle. No matter where you want him on that angle. So in other words, those are the three calculations. Those are the big ones. The first one, go X and go Y, tell you where he is. Then you have to figure out what angle is he at here. He's perpendicular to whatever the radius is at that point. And finally, the last thing is you have him lean in a little bit on his Z axis, and you get the entire motion. And that's what it looks like. So, and that's what's done in this scene right here. The horse is always running forward because he's always perpendicular to the radius that's pointed at him. And he's always leaning left because he's leaning over his Z-axis a tiny bit. You can lean him as much as you want, but I probably overdid it here. But I was trying to make the point that you can do it, okay? So let's look at the code itself and see what it looks like to see how that's all done. To begin with, you see that variable flight right there? I created that flight because I needed, that flight was the angle that he's at. I should have used a different word. I used the word flight. I should use angle, but I used the word flight. So basically, this flight is the angle that he's at. In other words, it's the angle that this is at as it goes around, okay? And the second thing is new X and new Z tell you where he's at in the circle. That's his location in the circle, okay? So that takes care of that part. Now, what that means is that every frame that comes up, I have to do the calculation, where is he on the circle? And that's based on the flight angle, okay? So let's go down to the routine itself. Here's the, right here's the render function, okay? I start out by simply casting his shadow on the ground. That's all I did, just did that. I said cast the mesh's shadow, and also have the mesh receive a shadow. I did that. The reason for that is because, I also made the floor receive a shadow, by the way, those three. I made the mesh receive a shadow because I was going to put an object on top of it and have it run under it to get a shadow, but I decided not to do it. So this thing right here, mesh receive shadow, well, actually there is a good reason for it. There's another reason for it. Because his body casts a shadow on his legs, and you want to catch that too. So I think that was the reason why I originally did it. I believe that's why I originally did it. Because I noticed his legs were light, and it didn't make any sense because he was shadowed on top. It was lit on top, shadow on the belly because it was shading. But then his legs were light, and I was saying, how does his legs get light? That was because I didn't cast shadows on him, which I should have done. You can cast a shadow on himself. Thing can cast a shadow on itself. That's part of the deal. So if you say, if a thing casts and receives a shadow, if it's like a big C-shaped thing, if it goes like that, the C part will shine on the other part as it goes by. So they calculate that. Okay, so then this right here, these lines right here are the ones that are critical. Can you read them all, those lines here? Okay, I start off with, every time it comes into the rendering function, I add 1 to the angle. In other words, I assume that he's 1 unit further down on the circle as he goes around. So then what I do is I say, calculate new X, which is his position in X, by giving it the radius, 150, plus flight, which is the angle he's turned at, he's gone around the circle. So that gives you the new x, that gives you his new position of x. And then GOY, I add 150 and I give flight to that and I end up with his new z. Those two lines right there give you, every time that flight changes, it gives you his new position on that circle, his new x and z. Okay, that's crucial. Then what happens is, the flight angle right here, see what am I doing, hang on. Oh, yeah, okay. This is a little complicated deal here, but basically what it is I'm just simply saying what angle is he at. See that math point, math pi over 2. That's the 90 degrees that flips him over, so he's always facing in the right direction. You have to know which way he's facing, because if I didn't put that there, he would run around like this. He'd always be going in the same direction, never change directions. This way he changes now, because that flight angle is changing for him. Okay, so that's where that calculation is done right there. That's a lot of stuff. You ought to just put this line in, and if you're going around a circle, just use that line and give it the same, whatever variable you want. And I'll show you what happens next. This is actually the animation update of the character himself, okay? I have to scale him to 0.3 because I decided that was before I was having a run in place, so I just made it 0.5. I made him half the size he was because he's a big horse. He's sitting in the middle of the barn. But then when I wanted him to run on a circle, I needed more room, so I squeezed him down a little bit so he can actually run in a big circle. So I said, okay, run in a circle you're only you're a third of the size you were. And then when I say new x is the position x that you're going to be at, and I got here, and new z minus 100 is the position you're going to be at in the z direction. The reason why I had to do that is because I didn't leave the origin, I didn't leave the center at 0. I moved the center. I wanted to move them away from us a little bit, so I moved them a little bit to the minus direction. I moved them 100 backwards. So in other words, the center of the circle is not quite. He would have been running, if this is 0, he'd be running around with the calculation of what new x, new z are. But because of the fact I'm actually having run back a little bit that way, I had to move them backwards. So I simply subtracted 100 from his z to move them back that way a little bit. So all the z's, it's like all boats rise with the tide. I add that minus z to every position he's at, and it always throws him back. So the entire circle moves back to a new position. Okay, so he's back there. Then I said right here, this rotation. I rotate the horse F angle, which is the angle I talked about before. It's the one that says, when he's over here, have him look this way. And when he's over here, have him look that way. In other words, what I'm doing is I'm saying I want him to move in a position so that he's always pointed forwards. And so that's it. That's what happens there. And this one right here, the Z rotation, why did I do that? Z rotation. Oh, the Z rotation is that always constant. That's pi over 6. That's like 30 degrees. That just tilts him over. And that's always the same. Now, he rotates on a Z, and he's always in the same, always math dot pi divided by 6, okay? And he's always in that position. And that's like a 30 degree. It's pretty serious tilt. But I have him at that position. So those are the calculations, and I say animate. So basically what I've done is, up here I calculate all the numbers I need, and down here I use those numbers to have them move around. Let me go to a different program and see what that looks like. Hang on a second. Close that. And I'll go back. And I'll go to the Flamingo. Actually, hang on for a second here. Hang on a second. I'm going to go to the Flamingo just here. All right, so, okay. There's the Flamingo, and that's when you get the Flamingo. It comes with the animation of its flapping and its legs dangling and all that, and its neck bending. that flamingo comes in just as a JavaScript, exactly the same thing. It's just called flamingo.js. I just bring it in with animation. I bring it in, and then I animate it the same way. In this program right here, he's not moving around a circle, so I don't do anything. But when I move him around a circle, I just want to show you the calculations are all the same. So what I want to do is I want to show you I'm moving in a circle. Then we'll talk about the code. Here he is right here. And I put the left and right light on so you can see both of the flaps. And both of those lights, by the way, at 500, they're way up there. So even though they're way up there, you still see it makes a distinction. You can see the difference in the shadows between one and the other. It splits them apart. It isn't so far away that it gives you one blurry shadow that's still separated. And that's how it kind of works. The bird himself, the reason why the bird's so dark is because we don't have we can't see the top of them. We're underneath them, sort of, and there's no shade down there. Put the ambient on, and he's back to pretty well lit up again. The trouble with the ambient is it's so bright. I think in a situation like this, if you wanted this to look good, you would reduce the ambient light to about a half, the intensity of the ambient light to about a half, but leave it on. Leave it on so you can see the bird, and then you'd also get strong shadows. This way, the ambient light's full blast, and it's wiping out all the shadows. See, ambient is an enemy of shadows, really. It's not you got to cut it down a little bit. So you have to reduce the intensity. Anyway, so let's look at the code that makes the bird fly around in a circle. Again, the bird was created at a certain elevation, and I might have had to move him. I'll see what happens in a second here. I'll take a look at it. But I'll show you how I got the bird in and how it works. To begin with, right down at the bottom here, you can see the animation, and that's the animation instruction, and it's called flamingo.js. That's what it was called when it was created. Okay, so in other words, it has the mesh and its animated movements. So then what I do up above, I do the same thing. I keep the same variables even. I call it flight. I set it at 0. New x is 0, new z is 0. That means everything in the beginning is 0. And now we have to do calculations from it. So I get down to the program. I add 0.5 to flight. 0.5, by the way, is half a degree because these things are measured in degrees. Okay, the flight angles are measured in degrees. Just like your turn angles are measured in degrees with your camera, the flight angles also measured in degrees. The problem you have is when you go to do a rotation, down in the instructions down here where you rotate something, then you have to think in radians. You have to go to the radian measure, okay? And if you, for any reason, have to do a radian turn and your thing is measured in degrees, you've got to do a translation. You've got to convert it. And by the way, that instruction right there is the conversion right here. This conversion right here. Flight is an angle times math.pi divided by 180. What that does is that converts the angle flight, which is in degrees, converts it into radians, because you want the angle the guy's at to be calculated in radians. So what I did was I added 0.5, which is degrees, to the thing, but then I said, well, the angle that I actually am going to have him at is going to be in radians. So what I do is I say, translate that into radians. So there's the degrees, multiply it by pi over 180, and it turns it into radians, and then you got it. That's a radian measure right there. The only reason why I add that math pi over 2 is because I want the guy to turn a little bit. As each angle, I want him to keep turning, okay? So that little blurb right there, you have to think about a little bit, and you might best start off by just copying it, stealing the code directly, and use it for your purposes. Down below here, we got the same thing. I said, and I shrunk them down to 0.2, and then I put them at y is 20. And the reason why is that y is 20 is because whatever position they had him in, and let's see, if I put it at 20, I don't know where he was originally, but wherever he was either up over the roof or someplace. He was someplace where I didn't want him, probably too high. So I said, okay, let's move him to 20 in the y direction. So that's the 20 height. That's where he is. And that puts it right in the scene. Not too high, not too low. He's right about 20. And if that didn't work, I would have tried some other numbers to get it to work. Okay, so you just use the number that works. Again, you've got new x and new z. Those are the two that are calculated up here, which tell you what his position is in x and z. And then this angle right here is the angle he's at. And so, and that rotation right there, I also took him 30 degrees and tilted him 30 degrees, so he's flying sort of in a tilted angle. And that's it. That's actually how to get them to move in a circle. If you wanted to move linearly, suppose you want someone you got a walking character, you want the character to move linearly across the stage or like that. You can do that. It's easy. You just simply put them in a new position. You just change the position number as you go. But you really got to be careful of it because, for example, suppose you press a button and you say, move in the X direction when I press this button. You will find he'll move right off the stage like a bullet because they move these things refresh really fast. So then what you have to do is you have to add like 0.005 or something like that, a really small number to his position, because when you press that button and he starts adding to his position, he's going to move really fast. So if you wanted to move slowly, you have to make the number very tiny that you add every time, okay? Like in that case, it would be, in the case of flight, we're saying flight is the angle he's going at. You would have some other variable like walking distance or something, whatever you want to call it, and you'd add something to that. But you wouldn't, 0.5 wouldn't do it. 0.5, he would right off the screen really quickly. So you have to have something that when you hold the key down or whatever, however you're doing it, that he just moves, or she moves just, moderately slow. I don't know if I've given you enough to work with here, but if you just steal code, which is what this course is all about, every cop in the country will be over here looking for me.
I've admittedly copied and pasted from programs too.
Oh, no, you can't. You can only steal our code.
That's what I mean.
I don't mean steal everyone else's code.
From our own stuff on the class.
Yeah, just the class code. That's all. You can steal
but
that.
I also type quite a bit, as you can tell.
We're allowed, and students are allowed to use, like YouTube stuff and stuff,
Right.
because we're not using it for economic reasons.
Financial
There's learning up with it, yeah. And so that's why we don't have much to risk in doing this stuff. And thankfully, YouTube's got a lot of stuff on it, so it's really pretty handy for us.
I've always still used like my own YouTube videos that was randomly uploaded, or my own photos just to be safe with mine.
Do we talk about this stuff here with the turning the lights up and down? Do we ever talk about that in this class?
The documents.
Let me talk about it now. Hang on, let me just get this. I want to get this in while I'm here, because it's something you may want to do. Right here, all these lines right here. What I did was I set up some switches so that when you hit certain letters, a light would change. Okay. See how I did it though. I want to see what I was doing here. Add backlight, scene, remove backlight. Okay, this one right here, if you hit 66, which is B, I believe. Yeah, this is B, is the letter B. If you hit 66, the backlight, okay, if the backlight's on, it'll go off. If it's off, it'll go on. This is like where you can hit these guys to the same key to turn them on, turn them off. That's a good way to do it. And what I did here, this is kind of a funny little code, but look, here's what it says. It says "bon off." Okay, now "bon off" is just the variable. It's either 1 or -1. That's all it can be. Now watch what happens here. You see that star? What that does is it says multiply this by that. And you put that back in here. So for example, if this was 1, I'd multiply it by -1. It'll become a -1. If this is a -1, when I multiply by that -1, it becomes a +1. See? So basically what happens is it's like a little cool little thing. When you hit it once, it's minus. When you hit it the other time, it's plus. So it goes back and forth between plus and -1. And over here, all I simply say, well, if it's equal to 1, turn the light on. Otherwise, turn the light off. In other words, if it's either going to be 1 or -1. If it's 1, turn it on. If it's not, turn it off. And so all that simply does is it tilts it back and forth. It brings it back and forth. And that's all that line does. It's kind of just a cute little thing. These variables, lon off, ron off, bon off, and aon off, those are just the variables that are used with ones and -1s in it to make sure it's switched on and off. That's like a little switching thing. Okay, so that's like a little piece of code that a lot of people use, that kind of stuff. So basically, if you want something, if you want to hit the same key to turn it on and off or back and forth or whatever you want to do, just set it up like this and it'll work the way you want it. Okay. I think that pretty well does this program. I don't know if there's anything else new in it. This little thing this is a little new right here. Let me show you the program again. Notice those words. These words are actually on the screen. They're not in this. They're not in the scene. They're on the screen in front of the scene. Okay. And the way I did that was I created a div. Did we talk about divs before? A div is just you just create this. It's not the 3D graphics. It doesn't do HTML. You're simply saying on this page, I want to put an area, a division, a subdivision, a place to put stuff. And what you say here in this code is, notice it sees the body right here. Notice this code is just in the body. That's all it is just in the body of the code. What I simply say is, set up a style, position absolute, so it starts at 100 from the left and 20 from the top, make it white, and make the font size 40 pixels. That's all I'm doing. I'm making these words in white, okay? So what it does is, it puts those words on the screen, on the front screen, and your activity is going on in the back over here. So it's just plastered on up in the front here. No, in other words, what it is just a bunch of words in front of your scene. That's all it is. But in order to get them there, I set up this style sheet in a div, and I said, make it 100, 200, so it's 100 from the left and 20 from the top. Start right there and write these big letters. And then I said, what do I want to write? I said, write the word instructions and all these words right here. And then I end it with a slash div. So in other words, what I say is div, do this stuff, and then I say words, 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 then I say slash div. So it shuts it off. So it turns it on with a div, turns it off with a slash div, and everything in between is treated like that. So all these things I put in here between the two are all going to be put in big letters and put on the screen. And that's it. That's pretty much the way it works. I didn't choose the font here. It used some nice font. It just, you can choose your font. You know, you can say font style and all that, but I didn't do any of that stuff. So I just made it big. That's all I did. Sometimes, by the way, when you choose your font, be careful about choosing your own fonts, because some people's machines don't have those fonts. And the trouble is, you tell them to put this font up, and this font doesn't exist. Big problem. So the ideal thing to do is let it default to the default font that they have. It's usually, you know, something's not bad. It usually looks okay. But if you want to get really fancy, here's what I do. I avoid the problem entirely. What I do, if I really wanted something to have that font and I don't want anything, I want some glorious headline font, what I'll do is I'll print it out and I'll put it in a JPEG, and then I'll turn it into a ping so that all of the letters are just, it's on a ping image really. And what I do is when I put it up then, it looks like letters, but it's really a picture of letters. And that way it's transparent and it looks nice, and it's always the same font. They can't get rid of it. It's going to look like that. So as you can fake it by making a picture of the font, which is just as good. By the way, if you ever have never figured it out yet, maybe you know this already, but if you have something on the screen like a bunch of big, nice font letters, and you want to copy those into a JPEG, just hit print screen. It's a button called print screen. As soon as you hit that, this goes up on the clipboard. And now it's on a clipboard. Go into your X and View program and say paste, or paste it back in, and in comes this picture in JPEG into your program. If it doesn't work, that might not work all the time. Come to think of it, it might not work at all. What you should do is go to Paint program and bring it in, because when you bring it into Paint, it will come in, and then it's sort of an image. Then what you do is you take it over to X and View, make it into a ping, and then you got what you want. Now let's copy it from X and View from Paint, put it into the exit view and turn it into a ping, then you get what you want. A lot of the work in 3D graphics and all web stuff is involved with using auxiliary programs that do stuff for you. The only reason why we're using the ones we're using is because they're all free. Paint is free, exit view is free, they're all free programs. I don't want to charge you for anything, so I thought we would do it that way. And so, anyway, that's the basic idea. I want to get to one other thing before we go anywhere. I put up a list of tools. When you're writing your project, you may want to use things and you may want to know how the tools work. So what I've tried to do is make sure that all the tools are online for you. So let's look at what's here. If I can find out what's here. Come on. Keep going.
Come on, baby.
Right here. It's right in where today's assignment is. And in case you guys haven't seen these before, or in case you need a pair of glasses because you can't see where there's points and there aren't points, hint, what happens is you turn a light on by telling the scene to add whatever light you want to turn on. These are the possibilities right here. I haven't talked about the point light, but I will right now. The backlight, left light, and right light, you've already seen. They're shadow producing, and they're already built in some position. But you can move them. You can simply tell it to go to a different place. I'll show you that in a second. But there's another one called point light. Now, point light's at 0, 0, 0. I just let it right in the middle. It doesn't do anything. Point light is like a light bulb, okay? But the problem with it isn't a light bulb itself. You have to put it in front of the object you want to be shiny. So, for example, if I had a ball right here and I want that ball to be really, really shiny, I would put that light right in front of the ball, and it would become like a sun. It would light it right up, okay? And you can also increase and decrease the intensity of it. But the point is that that's the only light that's weird. It's quite a weird light, and it doesn't have any, you can't use directions on it or anything. You can move it to different places. You can X, Y, Z, but you can't rotate it, and you can't do anything else with it. It's kind of got its own power. I believe, although I've never tried it, I believe you can change its intensity. I'm pretty sure you could do that, but I've never tried it, but I think it works. But anyway, that's the point light. The ambient light lights up everything. It makes no shadows, but it gets in the way of shadows. It lights every single thing there is. You can turn that off and you're in serious trouble. Everything goes black. So if you want to have ambient light that's not very bright, give the ambient light dot intensity, give it a 0.5 or 0.3 or something. Okay, well, you have a question?
Yeah. So you mentioned the point light, and like with my program, it would be helpful.
What?
And you mentioned the point light, and it's something I might use.
I never mentioned a point lighting. To you?
Oh, but just now you mentioned it. I mean,
Yeah.
And it would be helpful. I heard of it before. And so basically, when you position it, if you had like your object at 0, you would just put it at, say, like X 100.
Yeah. Okay, here's the basic rule. Don't put it inside of a sphere, for example. It won't light the sphere.
It's not like a light bulb inside a lampshade,
Yeah,
then,
right.
per se.
Right. That's the idea.
Okay.
Okay, so now, the next thing is, to turn the light off, you simply use remove. Use add to turn them on, and scene remove to turn them off, okay? Just use the instructions here. You can turn all of them off. When the thing first starts, ambient is on all, that's the only one that's on. And if you wanted to get rid of ambient, you'd have to say scene dot remove ambient to get rid of it, ambient light to get rid of it. This instruction right here. So basically, that's the only one that you could turn off. You can right away. The others are not on. You have to turn them on first. The intensity of the light changes. You can do anything from 0 to 1. That's the intensity. It makes it black, not there at all, to totally as bright as it gets. Okay, that's one thing. You can move the lights around to any position you want. I just used right light here, but any of the lights can be positioned, okay, except ambient. Ambient doesn't position because it's just everywhere, okay? That one doesn't do anything. Point light, I'd have to experiment a little bit more with this, but I don't believe point light will make shadows. I don't believe it's a shadow making type light. I think it goes in all directions and it's pretty bright. And I don't think it has that quality. Actually, I think there's a color shift in it or some weird thing. This right here is how you set the color of a light. You can set any of the lights any color you want. That number right there, whatever's in here, to get the number of the color you want, you have to think of two things. You have the light as a certain color, and the texture on the thing that you've got is a certain color. The two have to match somehow. If you know, it's like do you ever see those glasses with the red and blue? You look at red and blue, it's three-dimensional. The reason why they work is because the red cancels with one and blue cancels with the other. If you made the floor the same color as the light, you're going to get a weird deal. Make it red, you're going to get really a weird deal. So be careful when you're projecting shadows or anything on a colored platform, because that light could be weird. All you have to do, put in these zeros right here, is just go to HTML light color, just color, HTML color. It'll give you a list of all the colors, show you what they look like, and give you the 6 letters that numbers you have to put in. Just plug them into those zeros and you got it, whatever it is. So best just to get the kind of color you want. To cast a shadow, click right here. To make a thing cast a shadow, whatever the object is called, dot, you got to use its category. Yep.
Back in changing the color of the light.
Back to change the color of the light. Okay.
Would it be, where should I put it if I want to have an object that I can click on and have that change the lighting?
If you want to what?
If I want to have an object that I can click on in my program to change the color of the light.
Oh, how would you do that? Okay. Well, okay, first of all, the object has a name, like banana or something. Okay, so what you do is you say OB equals grab object, you know that thing, right? And then when you do that, OB now contains whatever object you clicked on. If you clicked on the banana, so what you say, if OB equals banana dot, say it's a plane, banana dot plane, if that's true, now you want to change the light, you simply, in the braces, you simply put whatever color you want, ambient light dot color, set hex, and give it whatever color you want it to be. It'll simply do that. Now, here's what I always suggest to you. Let me see if there's, let me go to a program that has a click thing. I want to be sure. Can you hold on? Tell me to go back to that. I want to just go finish this off, and then I'll go back to what you're talking about. Okay, let's just get this out of the way. So to cast a shadow, it needs two things. It needs something to cast a shadow, and it needs something to receive the shadow. And to stop those from doing that, by the way, all you have to do is say the same thing, like mything.plane.receive shadow with a capital S equals true. That turns the shadow on. If you change that to false, it'll turn the shadow off on it. Okay? It's possible you might want to do that on some occasions. So you can do either one. Video controls. You can tell a video to play or to pause. You got an MP4 and it's a texture. Okay, or it's a texture. So you simply say, well, wall zero's got a texture of waterfall. I want it to pause when it starts. You simply say wall0.video.pause in the render function, and it will pause it. And if you later want to make it go, then you put video.play. Now the problem is this. If you're in your render function, you put pause right there, it'll always hit that. So you don't want to do it there. You want to put that somewhere else. And you have to do it, mechanically somehow. You have to say, hit a button and turn pause to play, or hit a button to change play to pause. It's one of those things where you got to click a button or something, a key or something. So in other words, you have to control it up above. Don't put that in the render function. Put down wall.video.play up here, up out in the control area, where you have an if statement that says, if they do this, make it play. If they do that, make it stop playing, pause. Okay? There's several programs that we have with its keys, controls, and all you do is look at them. They all work the same way. They basically just switch the thing off and on with an if statement. Anyway, so you can pause it, you can do that. You can turn the volume down. In this case, you say video.volume and you turn it down, okay? That's that. The playback rate, which we've never dealt with before, you can actually change. You can make a movie run very fast or very slow. Problem with it is you got to be careful. This is the maximum for Chrome. I think Firefox is a little bit different. I think between I'd say between 0.02, .25 and 16, that might be, you got to experiment with that a little bit. The slow one is the problem one. I don't know how far down they allow you to go. And when you bring something down to speed, the frames go badoop, badoop. I mean, it looks awful. It doesn't do very good for you. High speed is better. You can get fast motion. So, for example, you could have a program that someone, you say you want to go high speed, hold down the key, and you hold down the key, and it keeps doing that key test. And when it sees it going, it could simply move it fast, move it at 16. And then when you let go, it could drop it back to its normal speed. One is normal. One is the regular speed that it goes at. Okay? So you can actually do that with an if statement also. You can tell a movie to go, that's like fast forward to some spot or backwards to some spot. You can move it to any current time that you want to. And what you do is to figure out what time you have, you simply open up and just take your movie and open it up. And some program you have will open it, okay? Then you look at the length of the movie. Supposing it's 600 seconds. That's all you got, is 600 seconds. So what you do then is, the current time will go between 0 and 600. That's the range it will be in. So if you want to jump it to any place, you can jump it to 300 or 400 or 0 or whatever. You cannot jump it to 800 because there's no 800. Okay, so you can only jump it to where it can possibly be. So you got to be careful with that. If you're making the current time a different number, make sure that it goes to a number that you have available that particular movie. The material opacity of a video. You can't make a PNG file out of a video. There's ways of doing it. They're called green screening. There's a way of doing it, but it's such a big rigmarole. I didn't want to get into it with you guys. So basically, what you can do though is you can make the entire video fade away, or the entire video come back very easily by saying wall.material.opacity. That's how you do it with our stuff. Though in the HTML world, all you have to do is say whatever the style thing is, .opacity. In this case, you have to say wall.material.opacity, or whatever object it is, .material.opacity. Okay, and 0, 1, 0 is invisible, 1 is thick. You can see it. In all videos, all MP4s, you have to have this line here. This is get new frame, and then the name of the object the movie's being put on. So you got to do that. Okay, there's no other way to do it. The audio controls are slightly different. You create an audio, but you bring the audio in here, like so. Get an audio, bring it in, and then inside of the JavaScript code, you give it a new name. You say, change that name to something. I changed it to fin. And then to make it play, all you do is say fin.play. You don't say fin.video or anything. You say fin.play with the open and shut, and it plays. Or fin.pause. No, that's how you make a regular audio sound play, okay? It also has current time control, the same as a movie. You can move it to forward or back, wherever you want it to be. It'll do that. And you can control the volume from 0 to 1. I noticed something on mine is that, and that's it. I noticed something on mine is that if I did 0.5, you can't even hear the difference between 1 and 0.5. So I brought it down to like 0.05, and then you can hear it. Then you can hear it drops the the volume quite a bit. So basically, the upper range has a lot of play. It doesn't really change it very much. When you get down to the 0.1, 0.2, 0.3, it starts to change severely. So you can do it that way. You can go down there, you can do it better. Okay, so that's that. I want to clean up some of this stuff because we haven't. This stuff right here is very important. When you open up your scene, you want the the camera, to be in a place where they can see what's going on. Everything, including the camera, starts off at 0, 0, 0. So all the objects, everything would be at 0, 0, 0. You'd be confounded by it. So what you do is you have to actually tell it to go to a different place. There's something I haven't mentioned a lot in here, but I want to be sure you know it. To make the camera drop down like so, you hit the space bar. That does that. And if you want the camera to go up, you hit either of the two Alt keys to bring it up. So it's either one of those will bring the camera straight up and straight down. That's the elevation, okay? And the arrows make it go forward and backwards and turn. Left, right arrow, turn you, like that. And those things are controlled by these variables right here. It's a line that's up in almost the beginning of the code in the Wallmaker program. What turn does is it tells you in degrees which way the camera is looking, which way you're looking, okay? And it's kind of freaky though. It's kind of weird because if you want to turn to your right, you have to turn negative degrees. So if I say negative 30, it'll go 30 this way. If I say positive 30, it'll go to the left, okay? Because it turns out on the y-axis, that's the positive, negative direction over there. So therefore, you can set turn, and you'll be looking in the direction you want to look at. You got up to 360 degrees. You guys may know this already, but I could turn 90 degrees to the left, minus 90 degrees, and I'd be at a certain angle. Or I can turn plus 270 degrees, and I'm at exactly the same angle, because you can go around and look that way. You're in the same spot. So it's possible to you're going to keep getting in the same spot no matter which way you go, over and over again. You just spin around, of course. So you can diddle with that. You can try it out, run the program, see where you are, see which way you're looking. D4, when you hit a forward arrow, it jumps 4 positions. Like one hit, it goes 4 positions. One hit goes 4 positions. Okay, and they're pretty tiny positions. If you wanted to, if you wanted to have your room a giant space so that you move slowly along a road or something in this space, what you do then is turn D4 to D1, or D equals 0.5 or something like that. Make it a very, very small, so when you hit the thing, it only goes a teeny distance. So therefore, if you hold it down, it's going to go teeny little distances. You're going to move very slowly. If you put it at 6, it's going to go like that, very fast. So what 4 is about what ours is set at normally. That's the speed at which you go forward and backwards when you hit the arrows. The other ones you're concerned about here is total X and total Z. That's your location in the beginning when you start. And it also keeps tabs of where you are all the time. So total X and total Z are used by the program, and I'll show you where. And what it does is it says, this is where the camera is, and these positions, and it figures it out. An elevation is the number that's controlled by the Alt key or the space bar. Space bar makes that 0 turn negative. The Alt key makes it turn positive, so you can go either way, up or down. And so the middle one starts off at 0 in the beginning. You're in the middle of the scene. The ceiling's up here, the floor's here. You're right in the middle, looking at everything. Okay? See what else we got here? See, like total X 100, total Z 100. What that would put you at is total X would put you in the plus direction, which is over here. Well, okay. Plus direction, which is over here. And the plus Z direction would move you back. So basically, you'd be moving back over here. And if you wanted to, you could rotate the camera plus 30 degrees, turn at 30 degrees, and you'd start them off in the upper corner where you're looking at stuff. And you can raise them up higher elevation to look at stuff. I got a program in there with the 2 spheres inside of each other, and what I did is I moved the camera to the left and back this way and up. So it's looking, then I had it turn minus 30 degrees or something, or 40 degrees to look at the scene. So it kind of looks at the scene in a kind of from the upper corner. Here's the code that you were asking about before. What happens is, if you want to change colors or whatever you want to do, no matter what it is, you in the key hit function, and be sure you put that brace in front. The key hit function should say key hit open shut, and then there should be a brace right there. Don't knock that brace anywhere. Keep that first brace up there, and you write inside over here. You say, okay, first grab the object that they hit with the mouse. Oh, wait, that's wrong. That should be mouse down right there. This should be mouse down. I made a mistake. That's mouse down. In your mind, make that mouse down. I added this to something. I should have done that. I can't change it right here. But that's mouse down. So when it was, where they hit bring the mouse down, it's going to come in, it's going to say, oh, you put your mouse down. So then what you say is, okay, what object did I put my mouse down on? Grab that object, so get its name. So you get its name now. You say, is the name of that object wall0.plane? That means you hit the wall 0. And if it is, do whatever's inside of these braces right here. In this particular case, it's kind of an interesting thing. If you say window.location.href equals, and then you put any website there, it'll jump to it. So if you want to go to one of your own, it's got to be one of your Alt Vista, whatever, even anything, any site you want to go to. You know, when they get there, they'll jump to that site and it'll open up. And then afterwards, I put a return. And the reason why is because there's more code down here in the mouse down, and you don't want to bump into that code. So what you have to do is make sure you never hit that other code. You want to do what you want to do and get out of there. Don't ever bump into any other code afterwards. Because if you do that, here's what would happen. If you click on something and you hit the thing and you don't get out, you don't put that return there, what will happen is you'll find that when your mouse moves a little bit, the whole scene will move. So not only will you get the click that you're trying to hit the object, but you're also using the control that controls the scene, moving it around. Don't want that to happen. So what you do is when you click down, if it sees that it's an object you want, then what you do is you get it, don't let it move anyways, just jump to whatever you want to do. That's what the return does. It says don't do anything further down on this program. Okay? Let me see if I got everything here. I do. Got to remember to change that. Now, the question you asked, did I just answer it, or was there another part of it?
I don't remember, honestly.
You hit the object, right?
Yes.
And then
That goes in the mouse down section.
yeah, the mouse down. And then you just change the color, right? And mouse down, right? Yeah, that's just a mistake right there. Glad we did this. By the way, I should tell you this course is a wonderful test example. When you program, if you're programming something that will fail and it just affects a few things, you can just look at it and fix it. One thing happens. If you write a program that's paying someone a salary and you miscalculate their taxes, 10,000 people will come after you and kill you. So the thing is, as you program, when you're working on these programs, something that's like what we're doing, we're kind of playing with it, drawing pictures and everything, it can fail, so it fails, whatever. But the mistake I made here, key hit instead of a mouse down, that's a serious mistake, because that means every student that looks at that might get the wrong impression. So you see, when you do things industrially, they're going to hit a lot of people. The mistake is much, much worse. So that means that when you're working on code of any kind, if suppose you're working in an office and you want to write some little funny thing, it may seem easy to write, but be sure you let people test it before you actually set it up, because otherwise you're going to have egg on you all the time. It always happens. You can never catch all your little things, and that's what happens. So sort of just a lesson you learn after a while. That takes care of that. Let's see what else I want to do here. Let's get back. The last thing I want to talk about a little bit is, am I down there? This thing right here. This is the scene here. This is the scene where I moved the camera back to the wall, over to the left, brought it up, and then had it turn. So I had to change all those things. I had to have the elevation change, I had to have it turn, and I have the X and the Y positions changed. So that it opened up in a nice, you can sort of see the whole thing kind of somehow. And don't forget, if you hit the space bar, it takes you straight down. And the elevation with the Alt or key brings you straight up. Okay, everybody see that? Just how you see it. That's all. These are the things I just put in because I wanted to be sure that I talked about them a little bit. In case you write a program you want it to look a certain way. A couple of things here I did. This one right here, well, let's see if I'll do it here. It's got a wall play. Okay, let's try this one. Some of these load a little slowly, but don't forget, it's because I have this frame, and this machine's like, you know, I mean, Abraham Lincoln lent it to me, so it's pretty old. This program right here is kind of, I did it in a kind of funny way. I think it's kind of awkward, but basically, it has 4 movies on it. They're all sitting there. And if you want a movie to play, what you do is you hit that sign right there, hit the sign, and then it will stop playing that movie right there, hopefully. There it is, so it plays that movie. If you want that movie to stop, just hit the silence, it'll stop the movie. Notice the sign disappears, I didn't want it to block the movie. So what I did is I clicked on it, and I did 2 things. One is I said, play the movie, I wanted it to play. And the second thing was, I made that sign opacity 0, yes. So I made it invisible. And that way you can see right there, you can see the movie. The whole movie is not in the way anymore. The silence sign is just a button that you can click that will shut stuff off. So any of these things here, no matter what they are, you can turn them on. Have you guys seen the robot that flips? Oh my God, look at this thing. Watch this robot. You need one of those at Port Alexander.
I don't know if we ever check out the electrical power requirements to support it.
I mean, can you imagine that, how what it takes to do that? You know, I used to teach robotics. That's like another universe. This thing right here is just like another universe. They have that down pat.
Not engineering.
This one, I like this one.
It proves they're not immune to mistakes.
You got to admit, they're moving right along. Anyway, this thing had those characteristics, and I just wanted to show them to you what they were. The other thing is this thing right here with the MP3. All this is a movie with nothing here. It's just scenery with. I took the mountain scenes, and I chopped away the clouds in the background. Not in this version, but in the next one I'm going to do. I chopped away the clouds in the background, and I replaced it with a movie of clouds moving. Okay? So what I did was, the way I chopped away them, I just simply made everything above the mountains transparent, so you can see right past them. And then I put a movie behind it like this, so the transparent part showed you the clouds through the transparent part. The way you make something like this transparent, there's 2 ways to do it. The easiest way of all is to go to Photoshop. It has a way of doing it that's really fast, or any program that does it well. XMView can do it, but here's what you have to do. You have to take it, if something I want to get rid of the sky, I would take it to paint, and I would get a paintbrush or something. Well, first of all, I'd X off a bunch of things and erase a bunch of stuff. But then what I would do is I would take a paint of a color, like some color that's not in the scenery, like bright red, for example. And I'd color the entire sky bright red, right along the edge of the mountains with the paint thing, make a nice red area above it. And then I would bring it to XMView and say, make all the red transparent, and it would knock it out. Then you'd have just the mountains, it works. I've done it many times, it works. And this right here, these bubbles by here, by the way, are, as you probably can see, if you go straight into the bubbles, watch what happens. Notice it goes out of the way? The reason why it goes out of the way is the dumbest reason you can imagine. What happens is the bubbles always face you. They're only flat little objects. So when you go to hit one, the center point just simply looks at you as you go by. That's all it does. But it doesn't really move out of the way. But it gives you that impression because of the way it looks.
So it prevents you from doing the Wizard of Oz, sadly.
What?
It prevents you from doing a Wizard of Oz type thing where the witch floats off in the bubble.
Yeah, right. Well, I mean, what I like about see, we haven't got a lot of tools here. We only got about, a couple dozen tools. With these tools, we can make anything. I mean, it's just amazing the stuff you can put together. You just have to think it through. This one here's got the movie behind it. This is just the mountains, and the movie clouds are behind it. It's, everything above the mountains is transparent, and in back of it there's this cloud scene moving. Another thing you can do, I just use the same clouds everywhere. It's possible, what I did was I told it to slow one of them down. And that way, what happens is these clouds come up, and when you look at the other window, they don't quite look the same way because they're in a different phase. So everything looks a little bit different than everything else. It's the same scene over and over again now. Like if I look to the left now, see that's that scene right there. If I look to the left, well, first of all, I also made it backwards. I also did that. But you can see that this one right here is different. They're all a little bit different than each other. Not very much, but after a few minutes they get quite different. I should tell you something about this video itself. I made this video of the clouds down in the Gavora Mall parking lot. I went to eat lunch someplace, and I took my camera and put it on the roof of my car shooting up at the clouds. That's all it did. And I left it there, and I came back later and took it.
That's awesome.
So, but here's the thing about it was, if I just made that film, took a strip of it, and I ran that film, it would go clouds, clouds, cloud like that. It would drive you nuts. So what I did was, there's another program that you can get online, which whose name I can't remember, but basically what it does, it allows you to edit, it allows you to wrap stuff and fade. So you can take the end and the back of this one, they will fade together. And that's all this one's doing. It's just simply fading one to the other. So it never goes but up. It just goes around, fades in and fades up. If you look at the clouds, they come in and they come out, they disappear, they reappear. And so it's got that little bit of a blending thing, which helps. You can see it now, it's really quite different. See, this one's open, this one's all filled in, so they're really quite different after a certain point. And the music, that was the other thing I was going to tell you about. This music, it's Beethoven. What I did was, I wanted something that was nice and pastoral, that was kind of like nice and slow. And so what I did was I said, okay, let me get a movement of something I knew was nice and slow. Well, when out there, they all sounded like tinny. The ones that were MP3s didn't sound very good. So I said, well, but you go on YouTube and you got the best players in the world playing there, and it really sounds great. So what I did was, I went to YouTube, and I took this frame right here, and I made it about that big. I made it very tiny as I could get it. They only let you go down to a certain level. And then I had the guy play the piece while I was recording the video of nothing, really, just a little tiny video. And then when I got it finished, what I did was, I put it in my scene as a video, but I put the little scene, which is only 4x3, I put it outside the walls. So it's showing a little teeny video over there, just a part of the scenery, but it doesn't get in the way. It's out the window. But the thing is that you're getting the full sound, and that's what's good. You got the sound, and you didn't have to deal with the video. And it doesn't slow it down because the image is so small, it doesn't take any time at all. So it's essentially the sound of an MP3, even though it's an MP4. That's very handy to do for sounds that you want to get that are real nice. You can't beat YouTube for sounds. One more thing about that. Let me just go back in here one more time here. Oh, wrong one, sorry. Retreat.
Abort.
Okay, abort. Another thing I did, and this one right here, if I get it up and going again, if you look here, it has a constant drift to the left. What the thing is doing is, it's moving the screen a tiny bit to the left. It's actually too slow in this one. But the screen's drifting very, very, very slowly. If you produce a scene, this is just a question of artistry, I guess. If you produce a scene that's supposed to be majestic and big and wonderful like that, when you hit the left arrow, notice the left arrow turns very, very slowly. Okay, because what you want to do is, if you want to give a lot of weight to the scenery, you treat yourself like, when you look at this thing, it's awesome. You have to look at it slowly. You have to turn slowly to give it that same majestic feeling as the mountains. So if you move forward, Forward's pretty fast on this one. Backward. You can use the mouse to go any speed you want. That actually goes, whoops, it goes any speed you want to go at. But if you use the arrows, it gives you that kind of slow, ponderous type movement. And that's actually a good thing for some scenes, if you want to make big scenes like that. It gives the impression, think about it this way, the whole trip here is you're creating a universe of some kind for people to go into, and you want the universe to be consistent all the way through, to feel consistent. So what you have to do is any little trick you can do to make it feel like it is what you want it to be, what feeling you want it to have. That's the object of the thing. No matter if you're selling something or presenting something or whatever it happens to be, whatever you're doing. And I think I pretty well covered everything I have to cover today. Oh, one thing I want to cover I didn't cover yet. Let me get to it quickly. We're almost out of here. The last thing is it's right here. These are the instructions for the final project. A lot of people have the projects. I get 2 of them already done, and the third one's almost done. So I have the projects that are lining up a little bit here. This is about right. This is about the way it starts off. You have to use wall maker. You have to have 3 objects of some kind in the room. Anything, any of the 3 objects you want to choose. Okay. And I don't care if they're all the same. You have 3 spheres or a donut and a sphere. I don't care what they are. One of them has to be a movie. Something has to have a movie on it. So I'll see that you can use those instructions. And you can use any 3 of the following. Have a transparency on something, use audio controls, video controls, sprites, put sprites in there somehow. And you can, any of these things you see here listed, okay? Change the lighting. You can put voice stuff in. We haven't done voice in 3D, but the same stuff that works over in the other area still works for us. That voice stuff still works. You can still put in the commands and say, listen, and it'll still work. They're built into this. They're built into graphics. So and shadows. You should have it before December 7th. That's a day that will live in infamy. Well, if you don't get your project done, it will. And that's it. Make sure it's at Alta Vista. Have any troubles with it, let me know. Get it as soon as you can. Get it in as soon as you can, because the last week goes very fast. It's almost over. And that's it. That's it for the class. I'll see you Thursday. We'll wind things up.